Okay, today we are going to talk about attributes of exponential functions. So exponential functions are going to have your x as the exponent, and they'll be written f of x equals ab to the x power. So normally the b will be in parentheses, and this is going to tell us if our exponential function is growth or decay. Okay, the A tells us our initial amount, which we'll talk about more when we do word problems. But it makes an exponential function if the x is the exponent. So the variable is your exponent. Okay, so it is a growth function if b is greater than 1. By growth, we mean it goes up from left to right. So if I start on the left side of this graph and move to the right, my exponential function is going up. Same thing, even though this one looks kind of different. If I start here, my exponential function is going up. It is a decay function if b is less than 1. So exponential decay goes down from left to right. So if I start on the left, go to the right, it's going down. Same thing here on this graph. Okay, so the graphs look a little different, but they're both decaying. One important feature of exponential functions is that they have what's called an asymptote. Okay, it's going to be a dashed line, and it's going to act like a wall. So the important thing to know, it's where your function goes flat. Okay, if you're just given an equation, it's going to be the number after x. If there is no number, then your asymptote is at 0. Okay, and since it's a line, it will be an equation. So it'll start as y equals, and then you'll have whatever number you're getting really close to. Okay, so here, if we look at this function from left to right, it's going up, so it's a growth. Okay, we have this dashed line. So even though it looks like the function's touching that line, it's not. It's just getting very, very close. So our asymptote is going to be y equals, and whatever number that's going through. So it's going through 2, so y equals 2 is going to be our asymptote. Okay, and it's a horizontal line, so that's hoi, so that's why it's y equals. Plus it's going through the y-axis. Okay, example 2, if I start here, we're going down, so that's decay. Okay, it has my asymptote marked, so we're going to look, see how it's going flat? That tells me that's where my asymptote is, so it's y equals, and it's at negative 1, 2, 3, 4. So y equals negative 4. All right, let's do the next one. So we're starting here on the left, and we're going down again, so that's decay. My asymptote's not marked this time, so we're going to go ahead and mark it. We find where it goes flat, and you just go kind of straight across the y. So in this case, it's going to be y equals 8. Okay, if they just give you an equation, you can either graph it or we can just look at it. So for growth and decay, we're going to look at the b value. If this number, if b is greater than 1, which it is, then it's a growth. Okay, your asymptote shows up at the end. So in this case, it's going to be y equals 3. All right, so let's find b and circle it. This time b is 0.5, so it's less than 1, so that's going to be decay. Then our asymptote is going to be y equals -1. All right, find the b, so it's the one with the exponent. B is greater than 1, so that's going to be growth. Our asymptote, there's not a number, so it's just y equals 0, which means it would be the x-axis. All right, so domain and range. Remember, domain is your x, and when you're looking at a graph, you're reading it from left to right. Range is our y and is read from bottom to top. Okay, remember, when you're reading this, if you see 2 arrows, that means it's all real numbers. If you see a closed circle, you need your inequalities that are equal. If it's an open circle, they're not going to be equal. Okay, so let's go over some of these. All right, so here we're going up, so it's a growth. We find the flat part, go across to the y-axis. So that is y equals -2. Our y-intercept is just a point. Remember, for a y-intercept, x is always 0, so it's 0, -1. Okay, domain, we're going left to right. So when I look at the left side, I see an arrow. When I look at the right side, I see an arrow. So I see 2 arrows, which means my domain is all real numbers. Okay, for range, we go bottom to top. So I'm going to start at the bottom. So this one can be kind of tricky because it looks like it's going to keep going down. But remember, that flattens. So that's not going down. But we do have this arrow at the top. So think of it for range, it's going to be like a dot. So we have y. It can't equal, it's never going to equal this number. So it's always going to be greater, or it's going to not have the line. So y is greater than -2 because all our y values are going to be bigger than -2 because we're going up. Okay, on this one, we're going down, so it's a decay. My asymptote is where it flattens. So that's going to be y equals 6. My y-intercept is going to be 0, 5. Remember, it's where it crosses the y-axis. My domain, I'm looking left to right. So it's going to be all real numbers because I have an arrow at both ends. Okay, my range, this time at the top, it flattens. So we have y, and my numbers are getting smaller. So we have y is less than 6. Notice your asymptote equation and your range have these same values. And that only works if you have arrows at both ends. Okay, let's look at these little next 2 that don't have arrows at both ends. So here we're going up, so that's going to be a growth. Our y-intercept is 0, 1, 2, 3, 4. Okay, domain, we're going left to right. So we have 1 point and 1 arrow, so I need 1 inequality. So I'm going to look at this x value, which is -6. So I have x, and my numbers are getting bigger. So x is greater than or equal to -6. It's equal because it's a closed circle. Then I'm going to look at my range. So same thing. My range is at 1, so we have y is greater than or equal to 1. Okay, this one is a growth. The y-intercept is 0, 6. This time, since I have 2 dots, that's when I have my in-between inequality. So for domain, we're going to look here. So the first number is -4. It's a closed circle, so I'm going to add my line. The next x value is 1. It's closed, so I need my line. For range, same thing, bottom to top, so we have 2 dots, so we need 2 inequalities. So the bottom range value is 3. It's a closed circle, so I need my dot. The top one is 10, and it's also closed, so I need my line.